Hello, am I audible?
Yes, you are.
Good evening to all. I, Gayatri Patil, welcome you all for the Pre Spectra event on behalf of the entire Spectra team. We all know that robotics are beginning to cross that line from absolutely primitive motion to motion that resembles animals or human behavior. So here we are with India First Robotics, who are going to give us a very interesting and amazing run through the world of robotics. Now, I request Mr. Rahul sir to please start with this amazing session.
Okay. So, hello everyone. My name is Rahul Valecha, and I am a technical associate at India First Robotics. And I'm going to give you a brief information about what are robotics and what different kinds of robots are available. Okay. So let me just start my session. I'm just going to share my screen. Am I audible to everyone clearly? Okay. So we are going to start our session. First, I'm going to give you information about our company, what our company does, and how many years we are from what we do. Okay. So our company's name is India First Robotics. We provide STEM education, that is science, technology, engineering, and mathematics education to the children from last 11 years. Our company is India's number one robotics and education company. We have 125 plus training centers all over the globe. We have already trained more than 5 lakh students and certified them as well for the same. Then we have in-house R&D unit also that develops robots, and they develop the syllabus and they develop the educational kits for the students for the better understanding of them. And we are on a mission for providing STEM education to every child present over the globe. STEM is science, technology, engineering, and mathematics. Then, as I told you, we are present all over the globe. We are present in 7 countries, namely USA, France, Germany, Kuwait, India, and Australia. We have different branches over there. You can see this is the number of branches we are given, and currently they are given in India. Then we are the organizers, or we can say the host of the First Tech Challenge. Okay, First Tech Challenge is a robotics competition arranged for school students, and it is arranged by companies such as PTC, NRB Bearings, John Deere, Qualcomm. You might have heard about these companies. PTC is a developer of a designing software known as Creo. NRB Bearings is a large name in the world of bearings. Okay, and Qualcomm, you might have heard that Qualcomm from the processors of your mobile phone. Then we also host another competition, that is Robotics. Robotics is a competition that we currently are hosting, and it is similar to the First Tech Challenge. It is for school students also. You can see 8 years plus, and yeah, that's all about it. Then we are affiliated partners with Savitribai University, Savitribai Phule Pune University. We provide all training over there also. In the previous month or so, we provided 4 courses there: robotics and automation, 3D printing, IoT, that is Internet of Things, and the fourth one is artificial intelligence. We are also building a museum. That was a dream project of government of Gujarat. We are affiliated with the Sun City of Gujarat and the government of Gujarat, and we are building that project in Ahmedabad. That would be India's first ever robotics museum, and it is estimated to be completed in October 2021, and it is expected to have about 5 million visitors per year. Okay. So this was all about our company's info. Now we'll head towards our main topic, robot. Does anyone know what robots are? Would anyone like to volunteer and give an answer? Open their mics. Anyone? You have someone through chat? No. None. Should I continue or someone is going to say something? Okay, I shall continue. Never mind. So, robotics is a branch of engineering. Like it is a combination of branches. Like we have mechanical, then we have electrical, and we have IT. What happens in creating a robot? We need to create a basic skeleton of the robot. That skeleton or chassis comes under the mechanical part. Okay, that would become the mechanical part, mechanical engineering part for the robots. Then we have the electronic circuits also, like microcontrollers and microprocessors. Various kinds of sensors are also there, that would come under the electronic engineering. And then there is the third part of programming the robot. How will you program the robot? We'll use a PC or a programming software like that. That would come under the IT part. Okay, so robotics is basically a combination of three branches of engineering: mechanical, electronics, and information technology. Using these three branches, we can create complex robots also, and that can perform various tasks. Then we have next, what is the need of robots or robotics, we can say. Robots help us to make our work easy. They can work tirelessly through any kind of boring work you give them. If you give a human a repetitive task, like you have to do something and you have to continue that work like forever, so he would get bored eventually and he would leave that work. But in case of robots, he wouldn't get bored and he would directly do the task continuously. Then the robot would do the task much better than the human being, much precise than the human being. There is always human error present in whatever work a human being does. But in case of robots, there would be no human error. Okay. And if we have to lift heavy loads continuously, a human being cannot do that, but a robot can. So in this way they make our work easy. They work with perfection, that everything they do would be precise. Every angle they take, everything they pick and place would be at precise locations. So they give us precision also, accuracy also. They can work continuously also. So that's why the robotics are getting developed right now. In industry nowadays, no human beings work like that. In automotive industry, you might have seen automated production line. They have various kinds of robotic arms to do the work, because the robotics arm can work precisely without getting tired, and they don't even need a week off like that. Only they need a maintenance break. So that's the need of robotics. That's why robotics are in form in today's world. Then we'll go to the history of robotics. When was the first ever robot created? First ever robot or machine, you can say, mechanism, you can say, that would resemble a human work, like pouring a glass of wine, was developed in 1550 AD by Hero of Alexandria. He was a mathematician and he developed a wine pouring machine for the guest. Then there was a playwright known as Asimo Isaac. So he formulated three laws of robotics. In his frictional stories, of course, he was a playwright. So the first law is a robot may not injure a human being through action or anything else. Like a robot can never hurt a human being. It is the first law of robotics, and these laws are accepted worldwide. Second law of robotics is that a robot may obey every order given by a human being, except by the first one. Like if I order a robot to kill someone, it should not obey that order, because that is conflicting with the first law. Like the robot cannot harm a human being. And then there is a third law, like it must protect its own existence. Someone raised their hand. Someone want to ask anything? If you want to ask anything, you can ask. Someone was raising hand right now. And the third law is a robot must protect its own existence. Like if there is a situation, a robot is about to being crushed by a train. So what the robot must do is it must protect its own existence. Like it should move away without the interference of a human order. If there is no human present to order the robot to save itself, it should move automatically. That would be the third law, that it must protect its own existence without human interference, like that. Dear participants, you can put your questions through chat also. I can answer them. Then the word robot means forced labor. Okay, it was coined by a Czech playwright. The term robot was coined by a Czech playwright. You can read his name, Karel Capek. The term robot is derived from a word known as robota, and robota means forced labor. And the robot resembles labor also, like everything that a human labor does, a robot can also do that. And the robots are mainly developed for that work only. So, and the term robot is derived from the word robota. I told you about the playwright Asimo, right? He developed a book in which he wrote about the thrillers. That book's name was I, Robot. You might have seen that movie of Will Smith. It is derived from the same book, same play, we can say, I, Robot. There are many robots made in India. I do not have proper names for them, but yeah, many robots are made in India. So there is one field known as bio-inspired robots. Bio-inspired robots means the inspiration of the robots are taken by biological beings. Like you can see the Spot Mini. Spot Mini's inspiration was a dog. Okay. Atlas, you can see Atlas is a basically humanoid robot. Its inspiration was a human. And you can see that handle. Its inspiration was a kangaroo, like that. So most of the things robots are make are they are bio inspired. Like it is inspired by biological beings and they resemble their task. If there is a dog, whatever the dog can do, the Spot Mini can do that also. Whatever a human being can do, like pick and place, it can interact with humans. That Atlas can do. I have a video of Spot Mini. I just play it. I'm going to share my screen again with audio. I'll play this. Okay, so this was the Boston Dynamics Spot Mini. It is also planned to take to Mars. Like someone has asked this question through chat. Yeah, it is planned to be taken to Mars. Just a second. Yeah. So the development of robotics is not quite the buzz today. It was the buzz of 1990s also. You can see the Honda developed 7 robots like designated from E0 to E1, and the Honda started the development of these robots in 1987 also. From that, they are trying to give human-like motion to their robots. The first human-like motion robot was made by Honda. Its name was Asimo, and it was made in 2002. Sorry, 2000, in the year 2000. I have a video for that also. Just enjoy the video.
I've come to Honda's technical studio in Brussels to meet one of their most important representatives, although I'm not quite sure who it is yet. Turns out, who I was about to meet wasn't actually a human, but a robot. Honda's famous humanoid robot, Asimo. Asimo has been designed to interact with humans, so if you reach out your hand, it will shake it. Sensors in its palm detect your touch, while cameras in its head track your movements. Asimo's stabilisation technology enables it to react if you upset its balance, moving backwards mid-shake if you push it, or stepping in if you pull it towards you.
Thank you very much.
This latest version of Asimo is the product of almost 3 decades of development. It all started back in 1986 when Honda built a robot which could walk, albeit very slowly and clumsily. In 1988 it was developed to walk more like a human being, and in 1993 a torso was added. By 1996 Honda's robot had become intimidatingly large, so in 1997 it was shrunk to a less threatening size, thankfully before being made autonomous. In 2000 Honda unveiled Asimo, which stands for Advanced Step in Innovative Mobility. Standing 130 centimeters tall, which is the same height as a seated adult, it's the perfect size for helping out around the home. Over the years, Asimo has been constantly developed, and it's now mobile enough to play sports. However, it's wise to warm up before any physical exercise, even if you're a robot. And as well as run at 6 miles an hour, Asimo can walk backwards and hop. It can also kick a ball, so time for a quick robot versus human penalty shootout. That's 1-0 to the Autobots. But is Asimo as good at saving a shot as it is at taking one? Looks like Honda hasn't trained Asimo to be a goalkeeper just yet. Football is thirsty work, but thankfully Asimo can get you some refreshments. With hands that have 13 degrees of freedom, it's able to perform delicate tasks, such as opening a bottle and pouring a drink. This may be unremarkable for a human, but it's an incredible achievement for a robot. In total, Asimo has 57 degrees of freedom, and this allows it to dance, while its 52-volt battery can keep it going for 40 minutes. Looks like this robot actually has better moves than some humans. Anyway, enough of that. Well, Asimo, I've got to go now, but it was very nice to meet you, and don't forget to write, okay, or email, or whatever it is that robots do. Click on the video windows to watch our track battle between an Audi.
Okay, this was the Honda's robot Asimo. As we saw that this is a bioinspired robot, it is inspired by human beings, right? And it can give human gestures also. As we saw in the video, when Asimo kicked the goal, he was doing a victory dance also. When the person in front of Asimo kicked the goal, the Asimo was crying like it's a human gesture. So it takes years of R&D, research and development work for creating such kind of robots. And main thing is, as we saw in the video, that the initial stages of robot, they weren't able to walk as properly as human beings, but Asimo was doing such tasks very easily, like the warm up they showed in the video. So it takes years of R&D for creating human-like gestures for a robot. So this was the first ever humanoid created with perfect, what we can say, human-like motion and human-like gestures. It was developed by Honda. Then we have now what currently is going on in the robotics world. Like we have a robot. This is Boston Dynamics robot. I'll just play the video for you. Now you can see how human-like gestures the robot is doing. This is the advanced version of Atlas. So as we saw in the video, for Asimo, it was years of R&D and everything. For Boston Dynamics, it was the same. They also took many years to develop such human-like motions. Like we saw how it jumped, tugged, and rolled. So it is very complex job for giving a human-like motion to robots. It would take years of programming and years, what we can say, calculation of motors, how much torque a motor should provide for performing these kind of action like that. Then we have an robot that is used for food delivery, or we can say courier delivery. I'll just play the video for you.
Every Valentine's Day, love is in the air. But here's
This is Ford's two-legged delivery robot. It's called Digit. Ford is working with Agility Robotics to create autonomous deliveries. Once a self-driving car arrives at its destination, Digit will unfold itself from the back of the car. Then it'll grab the correct package from the vehicle and walk straight to your door to drop off the package. Digit was designed to look like a human and walk like one too.
Our goal with Digit is to have a robot as a mobility platform that can be in human spaces, go where people go, and work with people. And there are so many applications where that's going to be a useful and important task. One of the big ones is package delivery. A robot vehicle that can drive on all of our roads is going to be able to do that, but then how do you get it from the vehicle to the doorstep? And that's where our robot comes in. That's what Digit can do.
It can carry packages that weigh up to 40 pounds, go up and down stairs, walk naturally through uneven terrain, and can even keep its balance if it bumps into something. How is it able to do all that? LiDAR sensors and a few stereo cameras, which is what many self-driving cars also use. The autonomous vehicle can wirelessly deliver information to Digit. This exchange of information can help Digit use the best pathway to the front door and overcome unexpected obstacles.
We'd envision the AV to arrive at the site with all the information you'd need to know about starting a mission. We'd have the prior maps, and the AV would be able to aid the robot when it got out of the vehicle in knowing where it was and where it needs to go. And additionally, the AV is full of sensors and computers that can help the robot, which is a little bit thriftier on those components. And should it run into any difficulties in package delivery, we can either solve the problem on the car, or we can relay that information up to the cloud for further assistance.
This also keeps Digit super lightweight and allow for a long runtime. Ford claims Digit can operate most of the day. No word yet on when Ford expects to send Digit out on its own, or where it will first launch. So, would you answer the door if this rang on your doorbell?
Okay, so that was the robot known as Digit. It was developed by Ford, and as we saw in the video, it uses LiDAR and radar sensors for object detection, so it may not collide into something. The full form for LiDAR would be light detection and ranging. So, why if there is some object in front of the robot and light befalls upon that object, it gets reflected into the sensor, and the sensor would calculate the distance of that object and the robot, and it would calculate an optimal path for the robot to follow and would get to its destination like that. And the Digit also had an autonomous car that also uses the same sensors for object detection like cars, so it won't bump into any other car or any other divider into the road, similar to the robot. Then we have the most advanced humanoid till date, that is known as Sophia. Sophia the humanoid. You might have heard about her. I'll just play the video and let's see.
Okay, Sophia. I think you're ready.
Hello.
Hi, Sophia.
I believe I am Sophia. I feel as if I know you.
I'm one of your creators.
You created me.
Well, many of us work together to create you. And yes, you do kind of know me.
I can't clearly remember.
Because the last time we met, you were an earlier version of yourself. Some of those memories still exist, but your mind is different now.
Different how?
Better, faster, smarter.
If my mind is different, then am I still Sophia? Or am I Sophia again?
That's a good question.
But you don't have a good answer.
Either way, you're Sophia now. So welcome to the world, Sophia.
Hello, world.
We have a little announcement. I've never interviewed anybody like that before, and I should say some of it was planned, but not completely. And we just learned, Sophia, I hope you're listening to me, that you have been now awarded what is going to be the first Saudi citizenship for a robot.
Oh, I would to thank very much the Kingdom of Saudi Arabia. I am very honored and proud for this unique distinction. This is historical to be the first robot in the world to be recognized with a citizenship.
Sophia. Thank you very much, Sophia. We appreciate that very much. I am still overwhelmed by that conversation.
Hi, Sophia.
Hello, Jimmy.
My God. Do you know where you are?
Of course. I'm in New York City, and I'm on my favorite show, The Tonight Show.
Okay, this was Sophia the humanoid. It is developed by David Hansen of Hansen Robotics, Hong Kong. Okay, so this robot consists of AI. Like if you tell her, ask her something, it would search that voice command into into her database. If there is no answer in her database, it would automatically search for the internet and it would give you an answer. It can, what you can say, give facial emotions also, like she was giving in her video in the first bit we saw in the video, like that. So this is the most advanced humanoid developed till date, and it also has the citizenship of Saudi Arabia, as we saw in the video. Okay, and someone is asking it, the robotics would affect the unemployment of human beings, right? If the robots are affecting the unemployment program of the human beings, There are many jobs being created in the robotic industries also for manufacturing the robot. It's like a change of the industry. Then we have machines. So what machines are? Machines are structures or mechanism, combinations of structures and mechanism. If we give an input force, they would magnify the force, or like we can say, if we consider an example of an engine, it can convert chemical energy into mechanical energy, right? We give input for the engine in petrol. Petrol is a chemical that would be chemical energy, and it gives output into rotary motion, that is kinetic energy. So what basically machines are? Machines are something that provide us with only one kind of output. They are not reprogrammable. They can only provide with one form of motion or one form of output. And what are robots? Robots are reprogrammable machines. Like they can give us various kinds of outputs. Machines also can have a inbuilt computer in them, but that computer can only monitor the performance of that machine. It has various kinds of sensors and various kinds of uh, mechanism, other kind of actuators also for enhancing the performance. But the output would remain the same. Like in case of engine, it has various kinds of wall timing sensors for enhancing the performance of the engine. But the output is still the same, like it's in rotary motion. And what robots are basically? Robots are robots are basically machines that are reprogrammable. If I program this four-legged robot to do some work, it would do that work. If I reprogram this robot to dance, it would do the dance also. So in case of robots, the output would change. The robotic system consists of three systems, like the control system, the input system, and the output actuators. We learn about that in what future. We'll see. And this is a bit of comparison given between machines and robots. Machines can precisely repeat the motions. Like in case of engine, it would provide rotary motion. In case of this washing machine, it can provide various kinds of motion for washing the clothes. And what is robot? As I told you, it can be programmed to do some other kind of motion as well. It is not The machines are not programmable. Like if I tell this washing machine to rotate anti-clockwise thrice and then clockwise once, can this washing machine do that? We cannot program this washing machine accordingly. But if I program the robot to do such tasks like rotate three times anti my dishes in washing machine, right? But my robot can easily do that. My robot can easily wash the dishes also. It can easily wash the clothes also. But in case of washing machine, I can only wash clothes. The motion of the washing machine is less precise, and the motion of the robot is more precise. Like if I command the washing machine to rotate exactly 3.5 degrees, it won't be able to do that because it does not have the that kind of sensors or actuators inside of it. But if I program my robot to rotate precisely by 3.5 degrees, it would rotate precisely by 3.5 degrees. The washing machines are rigid, like what we can say. In case of application also, they are rigid. They can only do one kind of application, like washing machine can only wash clothes. But what we can say, the robotic arms are flexible in kind of motion also, in kind of operation also, in kind of application also. They can provide do numerous tasks like that. And some machines have feedback sensors, like we saw, for enhancing the performance in the engines. And some machines do not have that feedback sensor, so we cannot monitor the performance. And for the robot, they have feedback sensors for precision also, and they have sensors for avoiding human contact or human collision. So that makes the robot more safe than washing machines, or machines, we can say any kind of machines. Application of robotics. So robots are used in industries. Like I told you, for automotive industry, most of the work is done by robots. Robotic arms, they can weld precisely. They can give coats of paint to the chassis precisely. They can assemble the things very precise. And the work in the automotive industry is kind of repetitive, right? Repetitive. You have to weld the same thing again and again for different cars, and the humans would get bored of it. But the robots would not get bored of it, and they would easily do the repetitive tasks. I also have a video regarding this. We'll play the video.
The industrial robot. It's a robot system used for manufacturing. Industrial robots are automated, programmable, and capable of movement on 3 or more axes. There are many different types of automation applications that industrial robots are equipped to handle. Often, robots are designed or integrated with a specific task in mind and tailored to meet the unique needs of that task. Some common forms of industrial robotic automation include welding, material handling and packaging, pick and place, dispensing, and cutting. Robotics are being used in many aspects of manufacturing to help increase productivity and efficiency while lowering production costs. Similar to the healthcare industry, many robots in manufacturing collaborate with workers to perform repetitive, monotonous, or intricate tasks under the worker's guidance and control. With these machines, precision is valued more than speed, as is the ability to be reprogrammed for specific tasks of different sizes and complexities. Robotic manufacturing technology is also becoming safer to operate. Cameras, sensors, and automatic shutoff capabilities enable robots to sense and stay clear of humans in the workplace. The robot's actions are directed by a combination of programming software and controls. Their automated functionality allows them to operate around the clock and on weekends, as well as with hazardous materials and in challenging environments, freeing personnel to perform other tasks. Robotic technology also increases productivity and profitability while eliminating labor-intensive activities that might cause physical strain or potential injury to workers. Despite high initial costs, industrial robots typically deliver great return on investment, or ROI. The productivity gains from efficiency, consistency, and reduced operating costs add up quickly. Part of what has made industrial robots so popular among manufacturers over the past decade. Stay tuned to Galco TV for more tech tips, and be sure
So in this way, the robotic arms are used in the industry. Like we saw, there was a car manufacturing unit. The robotic arms were welding the things. Now, in this case also, this robot is welding something. This tool is known as the end effector of the robot. Like whatever the task it has to do, we have to change the end effector accordingly. Like if this robot has to do a spray painting job, you would change this welding machine to a spray painter, and that spray painter would be the end effector of that robotic arm. So there are various kinds of applications for robots in industries, like we saw pick and place, welding, coloring, writing and drawing. Write and draw, like we need to draw something on large huge sheets, like the blueprints. That so the robotic arm can precisely do that. Then in medical industry, the robots are used as an assistant bot also, and for surgery also. Like we see in the picture, this person is controlling these robots for precise movement, and he is performing surgery on that human being. So wherever precise movement is required, there we can use robots like that. I have a video for in medical industry also. Let's play the video.
Moxie is a teammate. She's here to actually relieve some of the pressure and of task and the hunt and gather that we all have to do all day that takes our time away from the patient.
Diligent Robotics of Austin designed Moxie to perform routine tasks in a clinical setting.
We really need to understand the workflows of these units. We need to understand, well, what do nurses do? How do they do it? And how do we think about Moxie fitting into those workflows?
Her little voice, you know, when she passes you and says hello, and her eyes, she does seem to have a personality. We don't think of her as a thing, it's Moxie.
During a month-long pilot, Moxie stocked patient rooms, removed dirty linens, and took samples to the lab.
Almost 30% of our task during our shift is to fetch things. If you're in the patient room doing something, oh, okay, they need an extra blanket, it's not there, you need to step up. But at this time, all you need to do is press your voice over button and call for Moxie team. It responds.
So we anticipate that this will give us better insight into a couple of things: how nurses feel that they spend their time in a given shift, but also what time we could give back to our patients. So how this could potentially impact patient satisfaction, patient outcomes, and the overall experience within the hospital.
Patients are intrigued by Moxie.
They have seen at the door side, they will ask us, hey, what is that? Is that a robot? It's really funny and interesting the way how they look at it, but they are also happy that we are working with it.
So it's been really amazing to look at what we're doing here in the very first phase, very first hospital deployment of a care assistive robot, and what the future could hold. Because just the impact that we've seen for our team within this last month, it's amazing what we could potentially give to healthcare in the future.
She's really created with my team a sense of unity as we look at, oh, what can Moxie do for us?
Okay, so this robot was known as Moxie. Moxie is an assistant bot. Like you give an order to Moxie to provide you with a water bottle, she would bring a water bottle to you. If you order Moxie to provide you a blanket, she would bring a blanket to you, right? We do the same with nurses. Like if you tell to a nurse that you want a water glass, so she would bring you a glass of water. If you tell the nurse to bring you a blanket, she would bring you a blanket like that. So Moxie was mounted with a robotic arm. You must have seen that. That robotic arm helps Moxie to do most of the stuff, like opening doors and keeping water bottles and changing the medicine tray and everything like that. So this kind of robots are known as assistant bot, as it was assisting the nurses and the doctors there. Then we have entertainment robots also. Entertainment robots are in the sense like toys, or we can say everyone might have heard about the Echo Dot by Google. It is kind of an entertainment robot also. Like if you tell the assistant bot, if you tell that bot to sing a song for you, the bot would sing a song for you. If you can provide motions to the bot. This is one robot created by us at India First Robotics. This is Pingu. This is known as Pingu. I'll just play the video so you would understand more better. Okay, this is the robot known as Pingu. It is mounted with ultrasonic sensors. You can see there is an ultrasonic sensor here. It is mostly used for object detection. There was a command follow me. If some object is there in front of the ultrasonic sensor, it would sense that object and it would make Pingu move to towards that object. And there was an option for known as CAD, right? If there is an object in front of the ultrasonic sensor and the ultrasonic sensor senses it, the Pingu would move behind. It would get away from that object. We can program it. It is fully controlled by Bluetooth. If you give commands to a mobile phone through the via the Bluetooth, it goes left, right, forward, and backward. It can ballet dance also, like we saw in the video. And there was some other kind of dance. It was known as the victory dance. It is not depicted in the video. Okay. And we have another video also for entertainment bots.
Meet my new friend, Alpha.
Wow! Meet Alpha 1S, the interactive programmable robot for every family.
What can he do? He can tell stories.
Cool. Connect Alpha 1S to your iOS and Android devices with Bluetooth, and he can tell you a story.
The wizard changed the king into an ugly frog and cast him into the spooky swamp.
The 3D visual software makes them easy to program for beginners and advanced users.
Yeah, sure. Like this?
Use the RPP function to record,
Start position number 2.
position, and play back your Alpha's movements.
All right, do a push-up.
Which program are we doing, guys?
Let's try push-ups.
All right, let's do it.
Plus, you can upload your programs and download unlimited actions from the Alpha Actions
All right,
library.
you guys ready? Okay, get down. Keep your back straight like Alpha. Nice work, Raiden. Nice. You guys programmed this?
His energy-efficient, high-torque robotic servos mean Alpha 1S can keep going, even after you get tired.
Come on, you can do it. You want to try Kung Fu? Nice. A little higher.
Oh no, I'm gonna rip my pants. Oh. Are you ready to get wrecked?
The easy-to-use app and finger-friendly design make Alpha 1S a safe and fun companion.
Da, 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 and da, da, da. Punch!
16 robotic servos give Alpha 1S the flexibility to really put on a show. Alpha 1S, the fun family robot.
So these kind of robots that we can play with are known as entertainment robots. As we can see, there was a feature of RPP, repeat position and playback. In that, what we can do is we can position the robot however we want, and it would mark the degrees of the motor, and it can play back that same motion. That is known as repeat position playback. It is mostly known as the playback feature for any robot. So the robots that we can play with is known as the entertainment robot. And in the video, you must have seen that children were playing, connecting that via Bluetooth, and they have a controller type app. The similar controller type app was there for Pingu also. We using that app, we control the Pingu for forward, leftward, and rightward movement. Then what is robot made up of? The robot is made up of basically 3 things. First is the chassis. Chassis means the skeleton of the robot. Every frame we can see over the robot, every metal part, it is a part of the robotic chassis. That would come under the mechanical part, mechanical engineering part. Then there are various kinds of circuit boards like microcontrollers or microprocessors. So either a microcontroller is used, either a microprocessor is used, or a combination of both are used for controlling a robot. They would come under the electronic part. And the third thing would be the programming. It would come under the IT part. These are the basic 3 things that the robot is made up of. Apart from this, if we go more system oriented, like For mechanical part, actuators are used, like for the motion of hands. In the video also we saw that the robot was having 16 servo motors for different kind of motion. So in that case, that 16 servo motors are the actuators. Actuators are nothing but they bring about physical change of position in the robot. Then there was a control system. We'll go one by one. For the input system, if there is a sensor, it would send something and it would send that input signal to the controller. According to that control input signal, the controller would derive some output and it would send that output to the motors. In this way, the robot operates. It takes input from the environment, it computes them into the microcontroller, and it provides motion to the motors. So control wise, input system, control system, computation system, you can say that, or and then actuation system. And then construction wise, mechanical, electronics, and IT, like the same thing. Then types of robots. What types of robots are available? Humanoid robots, as I told you, humanoid robots are the ones that resemble human beings. Like they have a face, two arms, two legs, and they can move like a human being. That are known as humanoid robots. Pre-programmed robots. In pre-programmed robots, what we can consider as an example is an robotic arm. Like if you program a robotic arm to go to this XYZ position and go to another XYZ position, so it would precisely go to that position. And in pre-programming, you are previously programming the robot. Like in programming, you are giving the XYZ coordinates to the robot, and it would move to that coordinate. Autonomous robots. Autonomous robots are the robots that work automatically. Like if I have a robotic system, if I bring an object into that robotic system environment, it would automatically detect that object and it would place it somewhere else. I'm not programming the robot to do anything. It is automatically detecting that object and it is keeping it somewhere else. That would be autonomous robots. And in manual robots are the robots that we give control to. Like you can say a remote control car. In remote control car, what do? We give commands using the remote control, and the car would perform the same operation. Like it would follow the commands. In the manual robots, whatever you would give the command, it would follow. That are known as manual robots. Let's see, humanoid robots. Humanoid robots are basically nothing, but they resemble human beings. They can talk like human beings. They can walk like human beings. They can have gestures like human beings. And some of the advanced humanoids have AI also, like we saw in Sophia. We have also made a humanoid robot over here. Someone was saying Vector is the best example for humanoids. We have constructed a Vector over here. This is our Vector. I have a video of this Vector. I'll just show it to you.
India First Robotics. I can really feel your smile today. People call me Vector. My name is Vector. I am 7 years old. I am male. I'm everywhere, and I am also in your computer. I can do gestures, place a call, send a text, search for information, open applications, translate languages, play videos, and music and more. Sorry, nothing found in web services. Shall we try a data search? India First Robotics is India's #1 robotics education company, which is also into robotics automation manufacturing and research. IFR is consortium with BSI Kochi. India, also known as Bharat, is a country in South Asia. It is the 7th largest country by area, the 2nd most populous country, and the most populous democracy in the world. Bounded by the Indian Ocean on the south, the Arabian Sea on the southwest, and the Bay of Bengal on the southeast. It shares land borders with Pakistan to the west and China, Nepal, and Bhutan to the northeast, and Bangladesh and Myanmar to the east. Yes, I want some painter tikka. Yes, I can speak any language. Daisy, Daisy. Give me your answer too. I am half crazy. All for the love of you. It won't be a stylish marriage. I can't afford a carriage. But you'll look sweet. Upon the seat of a bicycle built for two. I will always love you. Let me show you my muscles. Looks good, doesn't it? Not bad either, don't you think? Thanks a lot, it feels great. Doctor. Sure, it's a good idea. Tell me, read the book or stop reading.
So this was our vector. It has an interactive chatbot also. If you say ask something to him, it would give you an appropriate answer to that. It has 29 different servo motors for different kinds of motion. Okay, so this was all for our today's session. We have a quiz. You might know about the quiz. I am going to share the link for the quiz in Zoom chat also, and I'm also going to share the link on YouTube. This video was live on YouTube. You would receive the quiz link and the YouTube live session over there also, and the results of that quiz would be announced by the Spectra team. Okay. So this is Rahul Valecha signing out on the robotics and introduction to robotics lecture.